So this game we're going to do is a Plants vs. Zombie clone. It's a top-down, very simple, modified tower defense type game. I'm sure you have seen the style. This project is mostly from scratch. There are two things I have here that are different than a from scratch version. The first thing is I have these little icons just for the towers. I just Google imaged tower icon and grab these to use as the buttons to spawn different towers. And then the other thing that I'm also doing that's different is I've imported this plugin, which is NGUI, which is a third-party UI system for Unity because I can't stand Unity's standalone user interface. And this one is nice and easy to quickly get things up and running. So this time I'm going to structure it slightly different where I get most of the pieces into the game before doing any of the programming. So a couple things that we need for the game. The first is going to be the base for where the game is going to take place. And that's going to consist of a ground, a set of tiles, and the little house that we're defending. Then we're going to have three other components that come in. Two of them are going to be modular. One is the tower type that we're going to spawn, and then one is the AI enemies that we're going to have, and then the projectiles the towers are going to shoot. So come in here and create just the floor real quick. Bring that to 0, 0, 0, and open it up. Have it 15 long and 10 wide. You can bring in the main camera. And the camera is going to be static. It won't ever really move from where it's positioned now. Then the other thing that we're going to have is a house on the left-hand side that just will stay there just for decoration and the goal of the game. Create a directional light, so they're always nice to have. Some hard shadows on there. And let's see. You can see them over here, but not over here. And then the most important part of the scene is going to be the tiles that we're using to place the units. So this is a block type system. We'll have an array of probably 6 by 6, 6 long, 6 deep tiles in here. So the first thing I'm going to do is I'm just going to create a tag because we're going to be using these tiles to determine where we're allowed to place towers. So I'll have a tag that's called tile. I'll also have a tag called tower enemy, so we can do an easy check to see if there's enemies in front of us. And that'll probably do it for now. Projectile doesn't need its own tag because it's going to handle its own collision detection. The enemy won't handle its own damage that's being taken to it. So I'll create an empty game object, make sure that it's on the origin because that way we don't have to deal with local positions. We only have to deal with global positions, and call this the tile folder. And this is going to have all the tiles in it that we're making for the scene. So let me make a little cube. It's going to be 1 by 1. And I'm going to give it a different material so that you can easily see it. So this will be tile 1. And then I'm also going to have another tile material called tile 2. because we want two different materials, so it makes a little bit of a checkerboard. So this one I'm going to drop down that color, and then the other one is going to be a bit darker, like that. So I'll put this, so here's our tile, and we want to make sure that it is right on the units section, so that when we create objects, we can say create object at 157 XYZ coordinates, and it'll be right on top of an object. So we'll do that by doing, I'm holding down Control to just snap it into place. As you can see up here, this X coordinate is moving in units of 1, and that's what we want. So we'll have the base over here, and we'll create, actually we'll do it a 5 up like here, so we have plus and minus 2. So these now going to be, oops, I selected too much. Copy these. We can even have a couple more. It doesn't matter how many tiles we do. It's just going to be a little bit of a pain when so let me get the, right here we'll have just the scene objects, and let me pull this floor and the house into that scene object. Make sure that the scene is centered again, so we only have to worry about local variables. So we'll grab the floor and the house and put them into the scene object. So then all of the rest of these are these cubes. Oh, I have an extra floor, and I think I have an extra, yeah, I do. I guess I copied and pasted those. Which means I think I also have another set of cubes that got copied and pasted, but I'll deal with those later. So right now I'll just select all of these cubes, tag them as a tile, and rename them as tile as well. The particular tile names don't really matter because they're all going to be held in this tile folder. Then I'll have every other one. I see. This one, this one, this one, this one, this one. Oops. This one? Nope. All right, we're good. So I'm just going to real quickly go through, checkerboard them like this. And then the other thing that needs to happen with these tiles, they're going to have a single script, each one, which is going to hold the information that tells the game whether or not there's a tower already on top of the tile. So we're going to create a new script real quick. I'm not going to put anything in it, but this is just the tile taken script. So I'll add that component to here. It was compiling. So tile taken. Add that in, and we won't touch that for a little while until we get into getting the towers and getting the tower placement set up. So the next thing we want is we're going to have a tower, which I'll have as a cylinder. Nice and easy for that. I'll scale it down so we're ready to roll with the correct model. Just like that. All right, so here's our tower type. That'll stay over here. Then we also want an enemy, which will be a cube. Simple here. And we'll just keep that right there. That'll be our enemy. And we'll actually want it a little bit smaller than that so it doesn't take up the whole system. And then we want our projectile, which will just be a sphere. Right in the middle. I'll have these all along the same thing. So there's Z position. We want to be 0, so they're all directly on the right line of this. Doesn't really matter, but it makes testing things a bit easier. Move this up a bit. All right, so now here we have our enemy is a cube, the cylinder is a tower, and the sphere is a projectile. Nice and easy there. So if you watched the last one we did, we're going to have the same type of health script on this, but the enemies will never regenerate health, so we don't have to have any programming inside the health script. All it's going to be doing is holding the health. It's never going to need to be more. It's never going to get healed. All it has to do is count down to 0 every time it gets damaged. So we'll do a very quick health script, which will be here, and we can remove the functions. It's not going to have any functions. All it's going to have is a public, I'll keep it as a float, even though it works as an integer, public float of health. And that's all that script does. It just holds that number. The two other things that the enemy is going to do is it's going to move and it's going to die. So, and it'll also do damage to the tower, but we'll do that one in a bit. So we have enemy move, and we don't need to make this work for the towers as well because the towers are stationary. So this is much easier than the last, the 2D, the top-down AI, because it doesn't need to navigate space. All it has to do is move left with a certain speed. So it's much easier to do this movement than the other AI. We don't have to create a navigation mesh. All we have to do is have it move left slowly. So to do that, we'll have a variable of movement speed. We won't need to do anything at the start. And in the update, we're going to be, we're going to translate it vector 3 left. And that is just a vector that's 1, 0, 0. There's a vector 3 left, right, up, down, forward, backward. And those are all some combination of 0, 1, 0 for all of the different ones. So it's -1, 1, 0, 0, all those. They're just very simple things that we can multiply with. So if I multiply the 1 by movement speed and time, delta time, then we get easy movement in a particular direction. And this direction never needs to change, so I don't have to get a special type of directional vector because it's always just going to move left. It's never going to move backward. It just wants to get to the end of the row. So grab the enemy, and once this compiles, you can see when it's compiling, we'll have it be half a unit. We want the enemy to be very slow. If you played the game, you know how slow that the enemies move. So this may even be too fast. Yeah, that's too fast. But it does exactly what we wanted. No matter which row it goes on, it's just going to start and start moving. If we wanted to get halfway there and then start moving faster, all we would have to do is modify the movement speed via a different script. So I'm going to have 0.25 be the speed for this enemy. Very simple. All it has to do is move sideways. So that script was only one line in a variable. The next thing we want to do is have the projectile. I think that was all I said that the enemy had, right? Oh, we also need the death. That was the other one. So here we go. We'll have death. And this one will be good for both the tower and the enemy. So we're going to have one extra Boolean variable, whether it's a tower or not, to determine whether it's giving you resources when it dies. So we have a public Boolean is tower. It doesn't really matter. In the previous one, when we did Booleans for AI versus player stuff, it was we always wanted to do is player because we only had one player and a bunch of enemy types. So toggling on one Boolean variable since they start as false was much easier. However, this one we're going to have multiple types of towers and multiple types of enemies, so it doesn't really matter which one of the variable, which type of Boolean. If you do is a tower or is an enemy, it won't matter. One of them you're just going to have to check on every time you put it, attach it to either a tower or the enemy, depending on what you choose to be that variable. But I'll go if it's a tower, and both of them are going to have health scripts. So I'll do a private health of a health script, and we'll do script equals so we'll grab the health. And then in the update for each frame, we want to check if the health script .health is less than or equal to 0. Then we want to do two things. If we're a tower, we want to do one set of instruction. Otherwise, we'll do the other set of instructions. So if it's a tower, we don't do anything to the resources, and we destroy the object. And we may want to do a particle effect. Otherwise, if we're an enemy, we're going to give resources to the player. And we're also going to destroy the game object. We'll do the resources script in a second to determine how much resources, and we'll do a give and take in there. Let me create the script right now so I can add it to the death script. So here we have, I'm just going to call this the money script. And I'm going to have it, all it's going to do, very similar to the health script for all of the AI, is it's going to have a public variable of money. Doesn't have to have any functions because all it's doing is holding the information about how much money we have in our game. So where that script is going to go, it's going to get attached to an empty game object that I'm going to call game logic. And the game logic object is just going to hold all the scripts that are kind of global gameplay scripts. So this money, either it or the camera can hold the information that determines where you're placing towers, but I'm sure there will be a couple more scripts that go into this game logic. So let me put the game logic script, the money script onto here. We'll start out with 50 units of money. And then in the depth, we're going to have we're also going to need a stat script, but first we're going to do a give money that is, we need the money script over here, so we have a private money. We're going to grab it at the beginning of the game, or when it's created. We're going to find it. And we're going to get the component money script. And now, because this isn't a tower, we're going to have money script plus equals. For now, I'm just going to have 10, but this is going to get changed depending on what type of enemy you killed. And that information is going to go in another script which has the statistics for the enemy. So we'll have the statistics of the enemy in here. We'll add this to the enemy. Let me change it first. It's not going to let me do that because money's afloat and I need an F there. So in the enemy stats, same as health and money, we just want to keep information here. So we're going to have a public float that is its worth. And then we're also going to keep a public float that we may or may not use, which is a movement modifier multiplier, in case we want to have a tower that can shoot ice bullets. Something that slows the enemy down will do a little bit of modification of the stats. We can add however many types of variables in here that we want, just like we did with the stats in the top-down shooter. So for now, what we'll do is we'll just keep this here, and we'll get the information of the worth. So on death, we're going to have one more private variable in here, which is enemy stats. And at the beginning, we only want to get this stat script if it's not a tower. So if it's not tower, then we want the enemy script to get set to this game object's enemy stats script. Now what we can do instead of this, we'll grab the enemy script dot worth. So we're going to add the worth to our money. Oh, money script dot money. That was the problem. So we're going to add the money to our money pool when when an enemy dies. So that's the enemy death script. Got the enemy move script, that works easy. We have our money, which we'll never need to use, and health. All right. So now we have this enemy. He doesn't have that death script or the enemy stats on him yet. That and enemy stats. And we'll also give the health and death script to the tower. Okay. Now we want to switch over to the projectile. The projectile is going to be very similar to the last game's projectile, except for we're gonna have it work in one script, because the movement portion of the projectile, it's only going to be going one way, so we don't have to find out its direction and put it there. It's in the same way that the enemy only moves left, the projectile only moves right. So its movement's going to be done in a single line, and so we can set up the projectile script in just one set. So we're going to have 3 pieces of information. The first one is going to be the movement speed. The second one is going to be how much damage it does. And the third one is going to be a 3D vector of the initial position, so that if it goes off the screen without killing something, it can get destroyed. So at the start, all we have to do is set the initial position to its actual position. And then the update, we're going to first do the move. So we're going to go the transform translate of vector 3 right this time, because it's opposite of the enemy. It's doing the exact opposite of the enemy. Times its movement speed times time delta time. Then we're going to do a check for the distance between its current position and the initial position. And if it's greater than, let's say, 15, that seems like more than enough space to get off the screen. I can even do 20. It'll be a little less important. But then we're going to destroy the object. We don't need to do any particle effects because it's going to be off the screen. It's not really going to matter. So that's the updates. Then the last thing we want to do is an on-trigger enter. And it's going to have a collider input, and if collision tag is equal to enemy, then we want to get the enemy's health component and remove damage from it. So I'm going to do the first part all in one line. So we'll get we're going to get the health component, health variable, and we're going to subtract damage from it. Then we want to destroy game object and create particles. So I'll also put in here a game object that's explosion. So that's going to be the particle effect. We won't use it right now, but it'll still be there for when we want to use it. All right, so now we will see how this works. The projectile needs to be turned into a trigger, and the enemy needs to be given I'm not sure, it needs to have the rigid body. Oh, I'll give it the rigid body. We're going to constrain it. And this is just because to have collision detection built in, you need a rigid body on one of the colliders. You can do this. The other way to do this would be to do a ray cast out forward, which we can do to detect if there's an object that has a tag of enemy. some small amount of units away from it, but this works just as well. All right, so let's see. It doesn't have any speed, and we wouldn't even be able to see it anyway because it has no damage. So we'll have a speed of 2, because we saw that the enemy has a speed of 0.25 and it's still moving at a reasonable pace. So giving this a speed of 2 should be fine. So let's see how much health the enemy has if it does a collision. I didn't check the collision. So I'll give the rigid body to both. Sure. Oh, is the enemy tagged? It's not tagged as an enemy anyway. It may not have been a problem. So have to make sure it gets tagged correctly. All right, damage was done. It got destroyed. We can check one more time to make sure that the health really did go down. Boom, 50 health. All right, the projectile now works. Now we have to have, now that the projectile works, we can just take it out and remove it from the scene because we're going to spawn them from the tower. The tower, I want to tag it as a tower. And the tower, all it's going to do is shoot. So we'll have this. Add it to the tower. Open it up first while it's compiling the initial step. So we're going to have this one work the same way as the top-down AI's shooting worked, where we're going to have a public cooldown, an internal cooldown counter, and the projectile that we want to fire. So what we're going to do is we will, in the very beginning, we'll just set CD equal to cooldown. So it takes a second to shoot its first shot. So if our CD is greater than 0, we're going to subtract delta time, to have it count down in seconds. Otherwise, we're not getting any mouse input. The towers are completely automated, so we're just going to fire every time the cooldown is reset. So here we have, we want CD to be equal to cooldown, and then we're going to instantiate our projectile at the current position and with a 0 rotation. Now this works, and the tower will shoot. However, we want the towers to be smart, and we only want them to shoot when something is in front of them. Yeah, you can have cross-lane projectiles, and then yeah, you can have cross-lane projectiles that'll go in a diagonal. It would you just use a slightly different movement script for them, but we won't, like, that's a very niche case for this type of lane combat. So it's not too difficult to add, and we may add that later on. But for now, we'll just have them stay in their lanes since we won't have enemies moving back and forth in lanes. So as I was saying, right now, if I were to save this and set this up on the tower, we have a shoot, compile, grab a projectile, and give it a cooldown of 6.6 seconds. If I have towers on all these lanes, no matter what happens, regardless of if there's an enemy, they're going to be shooting. Oops. So what did I do wrong? It waited the first time and then stopped caring. But you see the problem that they're shooting no matter what's happening, on no matter if there's an enemy in front of it or not. So when I fix this one, maybe the other portion will get fixed. So we don't want to just have it do that no matter what. So what we're going to do is we're going to check to see if there's an enemy in front of us. So how we're going to do that is we're going to have a ray cast. Physics ray cast. And this time we don't have a ray, we have an input position and a direction. So we're going to go from the transform position out at vector 3 right, in the same way that the bullet's traveling, the projectile's traveling, and then a distance of, let's say, 15. That should get everything. And the only thing that we do want to have is we're going to have a raycast hit called hit. And we're going to out hit. So if there's a physics raycast and if what got hit is an enemy, then we want to reset the cooldown and fire. So we only want to fire if there is an enemy there. Now, this works except for raycast hit gets blocked by a lot of things. So, and it doesn't continue through solid objects. It stops at the very first thing it finds. So as soon as a projectile is shot, the raycast is going to hit that projectile and not hit the enemy that's in front of it. So to fix this, what we're going to do is we're going to set the projectile to the layer of ignore raycast, and we're also going to set the towers to ignore raycast, so that towers behind them can also detect the enemies in front of them. So now, just the one should spaz out and shoot a million. Okay, so that works. Now the problem with the cooldown, so if our cooldown is greater than 0, we need to start counting down. Otherwise, we're allowed to shoot. We're setting this cooldown, this mini cooldown, equal to the cooldown. If I set cooldown, cooldown was 0. It wasn't a problem. I just didn't do that correctly. There we go. All right. So now we have towers that work correctly. Let's make sure that they do by doing this and lowering the damage on the projectile. So now we're doing raycasts through other towers, and they're both shooting. That's exactly what we want. All right. So yeah, with the cooldown at 0, it was doing at whatever, however frames per second, however many frames per second we were getting a projectile per frame. So now what we want to do is set up the creation of the towers. We don't want to have the towers set up. We want to put them there ourselves. So to do that, we're going to create a new script. We're going to have that as set tower. And what this script is going to do is it's going to hold all the towers that we're allowed to have in arrays and their price, because we want to reduce our money every time we spawn one. It's going to hold an integer number for the index of the tower that we want to spawn, and it is going to be able to pick out which tile we tap on to decide where to create this tower. Okay, so we have a couple of variables here. First, we want the selected number. Now that's going to be the index that we are taking when we say which tower to spawn. So if we have 5 towers in an array and we want to spawn number 2, then we have selected equal to 1 because it starts at 0. So we have that. We also have a game object array of towers and a float array of prices. And so each tower is going to correspond, its index is going to correspond to the price of that tower. So we'll be able to spawn tower number n and reduce the money by float price n. Then the other one, we want 2 other pieces of information, a game object of tile and the money script, so we can subtract money from it. So in the start, we'll just grab the money script, so now that we have that money script accessible, we can do exactly what we did yesterday when we got the point that we wanted to shoot the projectile at. We're going to turn our screen point into a world position point. So we're going to have our ray called ray, which is camera main screen point to ray. Input mouse position. And then we also want the raycast hit. Hit doesn't do anything. And then we're going to have if the physics raycast of ray out hit and of distance, say 20, should be perfect. If that happens, and if hit, finish that, parenthesis out, if hit.transform.tag is equal to tile. I'm not sure if I capitalized it when I created it. Check real quick. It's not capitalized, okay? If it's equal to tile, then tile game object hit game object. Like that. Otherwise, we want, so if we're hovering over a tile with the mouse, then that's the tile that we have currently selected. If there's nothing under it, we want to clear the currently selected tile so that the edge tiles aren't always selected once we move off them. So otherwise, we want to set tile to null. Now we have that. Now we can do get our mouse button. So if input dot get button down, or get mouse button down of 0, so left clicking. And we also want to make sure that tile isn't null, because we don't want to do this if we're not currently selected on a tile. Then we want to do a couple things. We want to get the tile's tile script, because we're about to set a tile. We're about to set down a tower, and we want to know if the tile is already taken by another tower. That's why we did that. Yeah, only every object is running the update function. It's a very minimal hit. There is a cost for every update function, unless it doesn't have anything inside it. It may even then there's a little bit of a cost, but almost none. But every time you have an object with an update function, there is some information being used by the computer. So the less update functions you have, the faster you're going to get. However, for things that don't have hundreds of lines of code in update functions, you're not really going to see that impact. As like even rendering a single cube is more than a lot of these update functions are going to do. The things that we're doing in update functions that are copied a lot, such as the health, the movement scripts, the rendering the next frame is 90% of that memory space being taken. So while update functions do have a performance hit, they're almost negligible, unless you're doing something that is some serious performance, a seriously performance damaging type of function, such as doing a spherical cast to get all the objects in a sphere. That's a big hit for speed. But as long as you're doing little things, adding numbers, multiplying numbers, as long as you're not trying to find objects like this, the function we're doing right here, there's a bit of a performance because you're doing physics casts, you're getting objects, but only the camera has this. This isn't going to be a multiple thing, so the game only has to do this once every frame, as opposed to every time for every enemy do all of this, or for every tower do all of this. So this one is just a single, relatively expensive function. I mean, relatively expensive compared to the other things we're doing. This is not a very expensive function in general. So here we're gonna get that tile script. So the tiles have this tile taken script, and we want to access it. So we're gonna call a tile taken script is equal to tile, and you get the component tile taken, and we're going to make sure that it's not taken. Is what did I may not have even had anything in here. No, okay. So for the tile taken, we want two pieces of information. We want a Boolean variable is taken, and then a game object that's the tower that is currently sitting on it if it's not taken. There's nothing inside here though. We're going to set those in the set tower script. So if the tile script is taken, is not taken, then we're allowed to create a tower. Variable. Okay. So we have this, the tile is free, so we're allowed to spawn something. The first thing we want to do is we want to remove the amount of money that is the tile we have. Oh, the other thing we need to do, we need to make sure it's not taken and we have enough money to create the tower. We don't want to go into negative dollars, and we want to only be able to spawn if we have enough money to do so. So we make sure that money is greater than prices selected. Right? Yeah. So if that's the case, then we subtract prices selected from the money, and we instantiate, we get a new position that equals the tile position, except for the Y position, because we want a special Y position because we don't want to make it inside the tile, we want to make it right above it. So, but for the X and Y, we go tile, get the tile's position X. For now, I'll have this at 0.5 F, and then tile Z. So let's look in here and see where a good Y position would be. Tower's over here, put it there. So I'd say that right here, you can just do it 1. 1 is a good position for the tower. Makes it nice and easy. So we want to be creating it we want to be creating the tower at that position. To do that, we just instantiate it there. And then we also, we're going to do 2 birds with 1 stone by creating, what it's called, right? Tile taken tower. We're going to set the tower to the instantiated game object, the instantiated tower that we're about to create. So that if we want to destroy the tower later, we have information about which tower we want to destroy. So we're going to kill here. We get towers selected. That position and quaternion identity like that. That's float, that's integer. That's why it was complaining to me. Because you can't get index of 2.5 of an array. All right, and now we also set the is taken to true, because now we've used up that space. Okay, you know, let me, good. All right, so let's see if this works. We have our game logic. I have 100 in here. I'm going to put this set tower into the main camera. We have a size of 1, price, there's only going to be 1. How much money did I have? I gave us 100, yeah. So I'm going to have the price be 50 for this tower. Oops. Delete this one. All right. So you should see that this snaps to a tile as soon as I overlap one. There we go. Just like that. Now I have $50. Oh, I need to make sure that it's greater than or equal to. Greater than or equal to. Because I had 50 and the price was 50, but it wouldn't allow me because I needed something greater. All right, so now I should be able to spawn 2 towers and no more because I've used up all my money. Awesome. Okay, here I'm going to create the first UI object. It's just going to be a label. The UI camera is done a little bit differently here, where all of this is going to have is how much money we have. For some reason, I'm no longer allowed to navigate. Okay. So we'll have the new label, and this is going to just have money. Oops. I'll just save this scene as for zombies. So here I'll create a new little script, and all this is going to do is be the money label. Add it. I'm done compiling. Go. Add that. We're going to get a little bit of information here. And all it's going to do is set its text equal to how much money we have. So to do that, we're going to have 2 pieces of information. The first is a public money of my script, and then a public UI label of, and then here on the update, the label dot text is going to equal money colon plus the money script. We can see how this works by we'll put in the label here, GameLogic's money script there. I'm going to turn the color to black, should be fine, and we can put it down here. Just like that. And now when we check out, there we go. Money 100, 50, 0. Did I have that?